I'm not going to full screen this. We usually keep these really informal anyway, plus everybody hits slideshows. Welcome to the thing. I already went over the Tennessee Entertainment Commission. I am going to full screen this because it's going to give me all the edit options. Here we go. So yeah, introductions out of the way. I'm Justin, blah, blah, blah. So quick show of hands, how many people have worked in Unity before? Okay, so a good portion of you. That's good. So as I mentioned earlier, this is just going to be the rollerball tutorial. It's out on unity.com, whatever. If you Google search for it, you will find it. It's one of the more popular Unity tutorials. And it is a bit on the older side, but like I said, all the basics are there. The fundamentals are there. Unity does frequently push out updates to their engine, but a lot of this stuff is going to stick around for a little bit. It might eventually become obsolete. I know that the whole entity component system is the new hotness. I don't completely understand it yet, but that's not the topic of tonight. What? Oh, okay. So I'm going to just kill time because David's laptop died. Into DK? Yeah, I do. I do. Okay, so David, I blame you. We're back. Yeah, I've got an outlet.
The rollerball, is that in the tutorials or what?
It's on Unity's YouTube page. I think, so I believe Unity just recently revamped all of their tutorials on their website.
It's there as well.
It is?
Yeah.
Okay.
I found it.
All right, hang tight. We're doing the thing.
I have to download it and then start it.
I still want to make that game.
We had a projector. I don't know where the projector went. Steve, you're killing me, man. There we go. Okay.
Try turning it on and off again.
Okay, back to the thing. Okay, so really quick, these are just some really quick key terms that we're going to cover tonight. So in Unity, everything is a game object. 90% of the time. Don't worry about that other 10%. We're just going to dive into this and get you guys making some stuff. So a game object usually has a couple of components on it. At the very least, it's going to have something called a transform. A transform is simply the position in space, so the XYZ coordinate. Its rotation, also expressed in XYZ, like the rotation on that axis. And the scale on that axis, so you can resize things and all sorts of stuff. And that's a component on a game object. You have the vector 3, not a component, it's part of the, it's a data type. It's a container to hold 3 floating point values, usually x, y, and z. It's really handy when you're working with transforms. Who saw the next bullet? Okay, rigid bodies, here we go.
Loose cable, huh?
I don't know if it's a loose cable or what. What are you doing?
It's up.
Okay. It might be a loose cable. I'm just throwing shade at David because I can. Okay, sorry. So a rigid body. That's how you apply physics to a game object. If you want it to run in Unity's built-in physics system, use rigid bodies. You also have things called colliders. Now colliders, those also work with the physics engine. As its name implies, it'll tell the physics engine when something is colliding with another thing. They're a little unique because you can also turn a collider into a trigger. So a trigger is very similar, except it doesn't react to physics. It'll just tell you, hey, something has triggered me. Somebody said something offensive. Wow, that joke fell flat.
Gliders reminds me more of how most people in Memphis drive.
Yeah. And the last thing is a renderer. As its name implies, it will just render the game object to the screen. You can turn that off. So all the components you can usually turn off and on. You can disable them, enable them. The game object, the game object itself, you can also do the same thing: disable, enable. There are a ton of functions associated with a lot of that. And we're also going to talk about a concept called the game loop, which is basically how your game runs. So, oh, what's up?
When it comes to like the renderer, like how do you know your scale? Where you get that?
What do you like the screen resolution?
Yeah, like how do you make it so like your textures are right scale size and they're not distorted?
That's your UV.
So if you're dealing with models, that's going to be determined in a UV map, which is a little bit outside of the scope, but I can find you some good resources on that. Alternatively, like if you're just working with like a terrain and you just need a tileable texture, usually you define that when you're actually making that texture. It's usually a good idea to keep textures in base 2, so like 128, 256, 512, etc., etc. The new hotness is like 4K textures, but you need all the video memory for that. So yeah, usually it's
Like when it comes to like texture versus modeling,
mhm.
like that's the standard today. Like back in the day when it was low bits, they had to use textures, but today should you model it?
So the workflow that a lot of AAA studios are using right now is that you have a modeling software, usually not Blender. I don't know why. People just don't like not paying for things. You model you sculpt your game object, then you go over, you do a retopo on it, which means you take that high poly mesh, you turn it into a low poly mesh, and you can bake in a lot of details from the high poly mesh, like shadows and stuff like that, finer details, and you can bake that into like a normal map or whatever, and then you throw that into like Substance Painter, and then you can Substance Painter will create all the textures for you, and then you bring everything in Unity. So really quick and dirty, that's how you do it. Anyway, like I said, outside of the scope for this, but I'll see if I can get you the hookup for that later.
Hang on just a second, Dustin.
I've been told
I'm
to
about
wait.
do something. It might break everything.
So yeah, the next slide I have, it's about the game loop. Basically what it boils down to is, oh, perfect. Here we go. What it boils down to is you look for input. If there is input, you process it in the update. Once everything is processed, you dump it out and you render it to the screen. Unity does that pattern already for you. All you have to do is call the update function and you are good. There are a couple variations on the update function. So update, just vanilla update, is called every frame. In a video game, if it's good, I shouldn't say good. A well-optimized game is going to run at about 60 frames a second, so you're updating the game 60 times a second. That's where this pattern comes in. Unity has a couple other variations on that function. So you have fixed update, which, as its name implies, it updates at a fixed rate. Frame rate is variable. If you have a lot of stuff going on screen, your frame rate can tank and your game is updating more slowly. Whereas with fixed update, it's going to be consistent every time. That's really handy when you're calculating things like physics. I believe Unity recommends that when you're looking for input, you put that in the update function. When you're applying physics, you put that in fixed update. And then for things like camera movement, there's one more variation on the update function. It's called late update. Basically, Unity will process all the other updates first, and then late update is last. So, like, the reason that's really handy, say you have like your camera moving and the player moving both in update, you can get some really jittery effects by doing that. So the camera can update first before the player, and you'll notice it like when you actually see gameplay. Everything is really jittery, it's not smooth. So by putting the camera motion in late update, you ensure everything else is updated first, then the camera moves. So it just helps things look a little bit more smooth. Okay, so, and this kind of ties into the upcoming game jam, or really any project. Usually your project comes from an idea. Ours is going to be really simple. The players evolve, they want to collect MacGuffins in the world, they go and they get the things. They win by collecting all the things. So let's break down what I just said. We have a player, they obviously need to move around. There's going to be a camera so you can actually see what's going on. Ideally, it will follow the player so you can see what's going on with the player. You're going to have the collectibles. You're going to have a really basic UI that'll tell the player how many points they have and let them know if they've met the win condition. You're going to have a game manager that keeps track of all of the necessary game rules, so in this case, just the score. And it'll update the UI. And you also need a level for all of that to live in, so your game actually has gameplay. Let's see, and if I remember correctly, Awesome, cool. So this is when we actually do Unity stuff. So, were any of you here for my last intro? It was the Rocket League version? No, perfect. So that last one, I had you use the standard assets, and it was a little bit of a mess because you had to go out to the Unity store and get the standard assets, and it was a pain. A lot of things went wrong. With this, we're just starting completely from scratch. So honestly, no, you don't need the current version. That's another good point. So if you're not on 2019.2, that's fine. A lot of this is going to look the same. Yes, 3D project. Oh, show of hands, who's trying to follow along? I forgot to ask that. I know Aaron is. Anyone? Okay, cool. I was just asking how many people were trying to follow along live. If you get stuck or if I explain something poorly, just raise your hand or throw something at me and I'll try to be a better public speaker. I should have opened this earlier, my bad, guys. You haven't missed anything yet. It's still loading Unity, somehow.
The Dell laptop that I got off Amazon for $150 right now.
Is it running okay?
It's got Windows 10.
Oh, all right, that's impressive.
There was a refurbished one to Amazon that I had gotten it for doing my online school work when I was in school to Daytona State College.
Cool.
For auto mechanics.
Okay, here we go. So Unity is up and running. So when you open Unity, it might look a little different than this. That's because I've got a custom screen layout. But anytime you open Unity, it's going to open just to a blank scene. Your scene is going to have a camera, a directional light, and usually the default lighting settings. In our case, it's going to be fine. It'll work perfectly. If you want to tweak your windows and kind of have it set up the way I have it. Sorry, I'm being invaded. Okay, so you can tweak your layouts by going to Window, and then I don't have my thing.
That wasn't me.
Hopefully you can see the screen.
Ah, that's frustrating. Technical difficulties, please stand by.
Still say it's a loose cable.
You going through the Elgato?
Yep.
Hey, there we go. Okay, so like I said, if you want to tweak Unity to make it look like how it is on the screen up there, the toolbar up top, just go to Window, Layouts, and then 2x3. That's going to change a bunch of stuff. It's fine. So usually what I like to do is move the Game tab right here. Up here, and I put it by scene. So if you see a tab, you can usually move it around and dock it wherever you want. And then I take my Project tab, and I usually drag it below Hierarchy. Your Project tab is going to show you in your file system where all of your game assets are living, where all your code is living, things like that. The Hierarchy is everything that's in that scene. So that's an important distinction. Okay. So your scene view is where you can actually work. You can navigate the scene view. So if you have a mouse, you hold right-click. And then if you use the WASD, that can pan the camera around. I think if you just use the arrow keys, if you don't have a mouse, that'll do the same thing. and that's how you navigate scene view. Everybody with me so far?
If you don't have a mouse, how do you like?
I use the back arrow key. That's a good question. So one way to do it would be to go to the game, or no, sorry, that's not the right way. That'd be how you move the camera. I don't know how you would do that without a mouse. Okay, cool. Oh yeah, there you go. Okay, so that's how you navigate your scene view. So let's go ahead and start building the game world. Unity has a couple of built-in primitive shapes. It's got planes, spheres, cubes, that kind of thing. For our level, we're just going to keep it really simple. We're going to have a plane for the ground and then a couple of walls that are just going to be some cubes. So to create a primitive, you right-click in your hierarchy, go to 3D Object, and then left-click on Plane. And then you should see a plane pop up in your scene. So you notice when we have plane selected, over here on the right-hand side in the inspector, you can see all of the components that are associated with that game object plane. We have the transform component up here, which, again, it has the position, the rotation, the scale, which are all vector 3s. You have the mesh renderer. The mesh filter. Then you have the mesh renderer. And like I said, if you turn that off, you can see the wireframe, and the collider is still there. It's just not going to actually render anything. So, like, if you've ever hit an invisible wall in a video game, that's one way how it's done. You just throw a wall up and you don't render it. But you keep the collider. That's important. Then we also have the mesh collider down here. If I were to disable this and I had a rigid body, it would just fall straight through. So that's another thing. If you've ever seen like cardboard cutout like scenery and you walk through it, there's no collider on it. So that's the ground. Right now it's just really bright because the sun is just going down on it, so we're going to throw a material on it to make it a little more interesting. So let's go ahead and create a folder to put all the materials into. So to do that, you just right-click in your project, create folder, and you can name this whatever. I just usually just call it materials because I'm boring. And then when you're inside of your materials directory, you just right-click, go to create, and then material. Then you'll see a default standard shader material that's just built into Unity. It has a couple of things that we can go ahead and tweak. Let's just go ahead and name that ground. Not a physics material, just a regular material. So materials have a bunch of built-in variables that you can tweak from the editor. The albedo, that's just, the base color. Here, let's actually go ahead and put this on our game object, and I'll show you how to tweak all this stuff. So applying materials to objects in Unity is really, really easy. You literally just click and drag. So we take our material that we created, you drag it on the ground, and you're done. And if you click on the plane, you can now see it has this ground material on it. So let's go back to our material. Like I said, you can tweak a bunch of... Yeah, what's up?
Can you also apply it by just dragging it up into the hierarchy?
Yeah, you totally could. So if I go to plane, and I think it's reset... Oh, here we go, reset.
So I can see sometimes it might be hard to do it when the 3D environment's too complex or whatever. You want to get the right one.
Yeah, that is one way to do it. Here, let me go ahead and throw just a cube in here real quick, and I'll show you that. Ground, I undid all the stuff on that. Make it blue again. So cube, same thing. Okay, but yeah, no, metallic, let me back up a little bit. So the standard Unity shader is built on something called PBR. This is a talk in and of itself, but the
Physically based renderer.
yeah, in short, it's PBR stands for physically based rendering. It's basically Unity's attempt at emulating properties from real life materials in a game engine. So you have things like, is the object metallic? Is it smooth? Is it rough? You can apply things like normal maps. A normal map makes an object look bumpy. You have height maps. It does the same thing, just to a little bit more extreme extent. You have occlusion maps, which help kind of bake in self-shadowing. You have detail masks, which they mask details. I don't really have a good way to show you that right now, but like I said, that's for another talk. TLDR materials are complicated, but don't worry about it. Okay, so we have our ground. It's not going to be really exciting to play on right now because it's kind of small, so we're going to blow up the scale on this. And another thing, for some reason, whenever you create a game object, I haven't quite figured out why Unity does this. It doesn't just automatically put that object at origin. It kind of gets an idea of where your camera is looking and tries to put the game object in the middle of the screen. Unity's trying to be helpful. I just find it really annoying. So I think it's a really good habit to just go ahead and zero out the position on the transform of... oh no, -3. There we go. Thanks, Jeff. I just think it's a really good habit to go ahead and zero out that position. It keeps things really clean. Huh? Oh, yeah, you can do the same thing with the camera. The camera's just another...
Plane. Okay.
Yeah.
That's how you keep it.
Oh, my lord, my computer is just chugging right now. Sorry, guys.
There's some 0-day exploit.
Yeah, probably. So yeah, we can blow up the plane by just plugging in different values to the scale here. I think I was messing with a value of 5. Here we go. So if you noticed, I only plugged in 5 to the X value and the Z value. If I try to scale up a plane on the Y-axis, it's not going to work. It's a plane. It's got one side. I can make it go away. Actually, I think I just flipped it. Yeah, I just flipped it. So you can't do that. And just a really quick note, this confused me forever. In Unity, up and down is Y. It took me a minute to understand why that is, but if you think about it, in a 2D game, you only have 2 planes, X and Y. Y is already the height value in a 2D game. So when you go to 3D and you add another axis, Z is just automatically going to be forward and back because Y has already been accounted for. I know it sounds like a really small detail, but it tripped me up forever. So just throwing it out there.
So like Blender does it the other way around.
Yeah, and
Z is up.
yeah, so all the game dev tools out there aren't consistent either because in Blender, Y is forwards and back and Z is up and down. So it depends on what you're working with. Unity is really good though. They have these little helper handles up here in the scene view. You can click on these and immediately just snap to that axis, and you also have the handles to move that out of ortho mode. Yeah, and you can just grab any of these handles and just move things around. And again, I'm just doing all this by left-clicking and dragging. So working inside of scene view is pretty easy. Okay, so we have our ground. Let's go ahead and create the player. So it's just going to be a sphere. See, and there you go. It snapped the sphere to like -30, -35, -40. I don't even know what's going on here. So we're just going to go ahead and zero out those values.
Oh, another thing to keep in mind is the units in Unity. 1 unit is usually 1 meter.
Mm-hmm.
So the physics kind of takes that into account. So just keep that in mind when you're scaling stuff up and down.
Right. It can be kind of useful, though, because if you really dig deep down into some physics calculations in your code, it's already in meters per second, so you're good to go. It makes math a lot easier. Let's go ahead and move the sphere up by 0.5 meter, so the ball will just kind of be sitting there. So, what's up?
So, is there any option that you can turn on that does like a snap? Is like, for instance, you had to use the math to figure out, it's a 1 meter ball, I needed it up to actually touch.
Mm-hmm.
So you had to divide it in half.
So,
Control.
yeah, so if you hold down Control and then you drag, the game object will snap in increments. You can actually define that. I'm really glad you brought that up. So if you go to Edit, and at the very bottom you see Snap Settings, you can define what that is. Usually if I'm trying to work with some fine details, I bump that down to 0.25. For our case, 0.5 meter is going to be fine. But yeah, no, like I said, this is just the regular click and drag. But if you hold down Control, it starts snapping.
And also, I think Alt will actually snap to the nearest vertex.
Oh, hey, that's moving my camera up and down. Hey, Aaron, I figured out how to do that. Hold. Here we go. Alt wasn't working for me.
Forget if it's Alt or Shift.
Yeah. So anyway, there's our player. So this isn't really too exciting right now. So you'll notice at the very top of Unity, we've got 3 buttons. We have what looks like a play button, a pause button, and then like a skip button. It's really just stepping through frames. If we hit play right now, we can preview what happens in the game. And spoiler alert, it's not going to be a whole lot. Yeah, here's our game. Nothing is happening. So let's make this interactive. So let's go ahead and throw a rigid body on our player. So to do that, you go over to the inspector with the sphere selected. Let's go ahead and name that player just so we can keep this kind of clean. And then in the inspector, you click on Add Component, you search for rigid body, and you just slap that on there. And the default settings are perfect. So if you don't have to do this part. I'm just showing you how a rigid body works. If we put an incline on our plane here and we play the game, we'll see that whoops, you can't see the plane anymore. Hold up. I should have noticed where the camera was.
Whenever you increase when you put the angle on it, your bottom of the sphere actually went below your collider, so therefore it just fell.
Well, no, it was looking from behind the plane, so it didn't even.
It's hard with.
Man, my computer is chugging tonight. There we go. And our ball now rolls down the plane because it is acting on physics forces. Okay. So let's actually start digging into some code real quick. So in your assets folder in your project, we're going to create another folder because organization is awesome. We're just going to call it scripts. And this is where all of our game scripts are going to live. So same thing. Let's create a C# script. So right-click in your empty scripts directory, go to Create, and then C# script. And we're going to name it Player Controller. So the goal of our player controller is to look for input from the user. We're just looking for keyboard inputs, and then we're going to apply those inputs to the player. Really quick. Oh, where does the input manager live, Devitt?
I got a question.
Yeah, what's up?
Instead of C#, can you actually use C++?
No. So right now, the only languages that Unity supports are, really, I think right now it's only C#. It used to support JavaScript. Can you still use JavaScript? Okay, so you can still use JavaScript. Don't, because it's about to be deprecated. Like, Unity is just going to flat out not support it anymore. But to answer your question, no. Right now, it's only JavaScript and C#.
Okay, because I know the games that I'm going to be programming for Xbox, those are C++.
It'll be similar.
Yeah, I mean, and you can build out to Xbox, right?
Yeah, so you can select your build target here too. So C# is, full disclosure, I've not messed with C++ a whole lot, but my understanding is C# is just an easier version of that. It's really just Java, again, from what I understand. So anyway,
Last programming language I ever used was BASIC.
haven't even touched that one. So anyway, but yeah, no, as I said, so our player controller is looking for input from the user, right? So to do that, we could just look for keystrokes. A better way to do that is to use the input manager. The input manager is also about to have a big update, but don't worry about it. It's fine. Oh, so the input manager is you go to Edit, and then I believe Project Settings. Yeah, Project Settings. And then over here in the left pane, you just select Input. The way that this is set up, you can, in your script, look for an input by name. And that named input can be associated with, like, here, let's do Fire 1. It can be associated with, like, left click or mouse 0 or, like, buttons on a controller or something. So it's really handy. It just kind of helps, I guess, abstract things out a little bit. But tonight, we're only worried about 2. We're worried about horizontal and vertical. And if you look, this is already set up for us. It can work with the WAS and D keys, the arrow keys on the keyboard. So we're just going to look for those 2 axes. So we're going to double-click on our player controller script. Wait for Visual Studio to do its thing, because I don't use VS Code like I should.
Does VS Code have all the debugging, like, does it interact as well with Unity as Studio does?
I honestly don't know.
It does have some debugging plugins for it,
Mm.
but code is just lighter. It still has IntelliSense and all that,
Yeah,
just not all the full debugging stuff.
gotcha.
Cool. So yeah.
You get more like
Oh.
Visual Studio, you gotta take it out a ton of different plugins and everything else, and then at the end, you might as well just be using Visual Studio if you have it.
Gotcha.
Okay, so when you create a brand new script in Unity, this is what it's going to look like. It's already going to have two functions in there for you. You're going to have start and update, like I mentioned earlier. Start is really easy. When the game starts, it will execute whatever code is in that block. Update, like I said earlier, runs every frame. So for our player controller, we added the rigid body component from the editor earlier. So what we want to do is reference that rigid body. So to do that, we are going to set up a private rigid body, and we're going to just name it RB. And to actually set up that reference, we say our rigid body is equal to get component, and we define rigid body here within.
Text bigger.
Oh yeah, sorry guys. Oh, too big. Do 150. Is that okay with you guys? 150.
I'm still learning.
Oh, Visual Studio? Okay. Well, I'm not doing anything super complicated yet. I won't go too quickly. So now when the game starts, Unity will run the code and start. We will get the rigid body component and actually assign it to that private rigid body variable that we typed up earlier. So that's start. So let's start worrying about our inputs. For our inputs, we want, let's make two floats. So again, we're going to have private, float. Going to name one horiz input for horizontal input, and then another one, and another one for vertical input. So all this is saying, private just dictates the scope of our variable. It can only be accessed from this class. A float, if you don't know, is just a floating point number. And we've just named those. So let's actually assign some values to those floats. So let's do horizontal first. So on update, we want our horizontal input to be equal to input get axis. And this is where we define the horizontal axis from our input manager. So literally all we have to do is spell out horizontal here, and Unity will go and fetch the inputs from that axis and apply it to our horizontal input. Yeah, what's up?
All right, so this may be more of a C# question than a Unity question.
Mhm.
All right, so you're defining the variable at the top,
Mhm.
rigid body, and then this get component with the brackets.
Mm-hmm.
What does that apply? It's going out and getting. Is that going out and getting an object and applying it to that, or what's?
I think one of the real programmers could answer that better.
Okay.
It searches the object for components of that type. Because I think you can only have one component of a certain class type or a certain
I think it's actually the first, because you can do get components with an S that like returns a
Mm-hmm.
list
And
or something.
Yeah. Full disclosure, I'm not a professional programmer. Like, I'm super hobbyist, so I might say some stuff incorrectly.
But
Feel
it
free to
is
correct
taking-
me.
It does take a generic, and so it's doing that. It's searching for that type.
That's cool. I'm just not real good at C#, so I don't know if it's some kind of magic that I wasn't aware of.
It's the short answer, yes.
But you're gonna put the player controller onto the player, right?
Yeah, we haven't done that yet though. So
That's how it knows what.
yeah, exactly. Yeah, sorry, I haven't connected all the wires yet. But what Jeff said is 100% correct. So we're just going to do the same thing for our vertical input. So input, we get the get axis function. Vertical. So we have fetched the input from the user, and now we need to apply it to the actual player. So like I said, you look for input in update, you apply physics in fixed update. So call fixed update right there. and we get our rigid body. And we're just going to use one of the built-in rigid body functions, add force. It's the simplest implementation of adding a force to an object. And it takes in a vector 3. And for those of you that aren't programmers, I'm not either, and I can still do it, so don't worry about it. If you're confused by anything in here, if you go to the Unity documentation, so here, let's look at what I'm working with. I'm looking at a rigid body, and I'm trying to add force to it. So if you literally just Google that, you'll go straight to the Unity documentation, which will explain how you use this function. So it'll only take 2 arguments. One of them is optional force mode. You don't actually have to define that. But all add force is looking for is a vector. And if you remember, a vector 3. And if you remember, a vector 3 is just a container for 3 floating point values. We have 2 of those from our horizontal and vertical input. And because we're not worrying about jumping, we don't care about the 3rd one. So in add force, remember, it's a vector 3, so you do new vector 3, and you plug in our values here. So we have our x value, which is the horizontal input. Remember, y is up and down. We'd worry about that if we were jumping. We're not, so it's just 0. And then we want our vertical a vertical input for the z-axis. So that should work. So if we go back to Unity, Unity will just kind of look over the code we just wrote. If there was anything wrong with it, it'll show up in the console. Please dock the console. Here we go. There's nothing wrong with it. We're good to go. So let's go to our player object, go to add component, and this is where we hook up the player controller script that we just wrote. So now when we press play, it slowly does things. Here we go. So if we press WAS or D, the ball starts moving around, but it's really slow. We can do some really cool things right now with this. Before I go any further, are you good, Aaron?
Yeah.
You are?
I mean, it's not letting me use Visual Studio saying around my client.
There's a community edition that doesn't require that. I think the version that Unity installs does that, but yeah, there's a community edition where you don't have to buy it.
Okay, well. Okay, so let's do the cool thing real quick. If you make a public variable, we'll just make it a float. We'll call this speed. And we go back to our player controller in Unity. You can now see that we have this speed field here in the component that we can play around with from the editor. So you don't have to go and mess with your code every other time you want to make a tweak. So let's actually apply the speed. If you go down to where we're adding the force on our rigid body, and you multiply the input by speed, we go back into Unity, and let's plug in like 10 for the movement speed. We roll around, and it's a lot snappier. Okay. So that's, yeah, what's up?
All right. Tell me if I'm being a pain.
You're fine.
But all right, so do all variables that you're defining in that code show up in the inspector?
So yes and no. By default, if it's private, no. But if you go into debug mode up here, so up in the right-hand corner, you're going to have like this really tiny burger bar by this lock. You click on it, and you go to debug. You get a lot more information. So here, you can see that we have horizontal input and vertical input. So you can see it, you just can't tweak it.
I didn't know about that.
Can you update it? Can you update the when it's in debug mode and you have it running? Can you update it in the inspector?
I don't know. Let's find out.
Cool.
Yeah, so with the public, you can. Private, I'm trying to click on it. It's just no dice. So debug mode is kind of a pain to work with when you're trying to build things rapidly. For debugging, it is great. I've actually had to use that a few times for like some side projects. Usually I just stick to the normal mode though. Okay, players, oh yeah, camera follow. Okay, so we're gonna set up the camera follow. First, let's get the camera in a better position. So let's bump this up to 10 on the y-axis and rotate it by 45 degrees on the x-axis. And oh no, my camera. What have we done? There we go. Okay, sorry. The position is 10 on the y-axis, negative 10 on z, and then we just rotate it at 45 degrees on x. You could do this a really cool thing with game objects. You can parent and child them. So if we take our main camera and we parent it to the player, it'll give us most of the functionality that we want. If we move the player, you'll notice the camera's moving. If we rotate the player, that's awesome, the camera moves. So at first glance, it's like, hey, we're done, let's move on. But if you remember from the specifications, I said we want a camera that doesn't make the player sick. And this is super broken. So there's a way we can fix that with code. And it's a really simple script. So let's unparent the camera.
Hey, Justin, if you lock the rigid body rotation, will it still move?
Let's find, you mean on the player?
Yeah.
Let's find out. Okay, so rigid body has a couple of things that you can do. You can lock it on an axis. So if you go to constraints on the rigid body, you can freeze its position, its rotation. Let's freeze all of its rotation and just see what happens. Oh yeah. Here, thanks, Jeff. So here we go. This works. I'm going to show you another way it works. Okay, so let's go to our scripts. Let's create a new C# script and call it camera follow. And I've actually used this camera follow script in a couple of other of my games. It's really simple. I somehow managed to screw it up every time I write it, though, so bear with me. So it needs two things. We need a reference to our player. Our player is just a game object. And it's going to be public, so we'll expose this variable to the editor so we can just drag and drop stuff because I'm lazy. We also need a private vector3. We're going to call this one offset. So in short, what we're trying to do, we want the player's position and we want the camera's position. We want to measure the distance between that and take the difference. So to do that, we go to start. We're going to say offset is equal to player. We want the transform component of the player, and then of the transform component, we want the position information. And then we subtract that from our current transform. The script is going to be on the camera, so what we're doing here is we're basically saying camera.transform.position. So we've taken the difference of that distance and applied it to the offset. And like I said, camera movement, you typically want to do that in late update. So all we have to do is change this to late update. And every late update, we want to say we want the camera transform, we want its position, and we're going to set its position equal to the player position plus the offset. So we save that, we go back to Unity, click on our camera. Same thing, add component. We want our camera follow. We can see here that we have an empty slot for our player game object, so we just click and drag the player from the hierarchy and dump it to the camera follow script. And now, if I set that up correctly, the camera should follow the player. Now remember, the camera's not parented or anything. Oh, this is super jank. Where is my camera? Oh, I think I see what's going on. Okay, so somehow I'm applying my offset incorrectly. Welcome to game dev. Things go wrong live. I've practiced this like 3 times and I still screwed it up. Let's subtract the offset and see if that does what we want. There we go. So yeah, just a really simple fix. Occasionally things go wrong, but it's really easy to just... Let me back up. I find it really useful to be able to visually see what's breaking. I suck at coding anything else, but that's because once things get really complicated logically, you've just lost me. But if I can actually see what's breaking, I'm good to go. But yeah, no, you can see that our camera follows the player. It's smooth. We have no constraints on the rigid body. Nothing is parented, and we're just good to go. And it doesn't nauseate the player, hopefully. So there you go. We have our camera follow. Let's go ahead and set up our collectibles. This is going to dive into something called prefabs. Prefabs are life. If you take only one thing away from this, please let it be prefabs. So really quick, we're just going to create a new folder. We're going to call it prefabs. In our hierarchy, let's go ahead and create a cube. Zero it out. And just to make it look cool, we're going to rotate it on 45 degrees on all axes. And let's scale it down just a touch. Whoop. Yeah, you can really see how powerful these scaling tools are. Like once you get a model, like say you get a model from the asset store and it's too big, you can just scale it down in the engine. So Unity has a lot of built-in stuff that makes life so much easier. And our collectible is kind of falling through the floor here, so let's go ahead and move it up by, again, 0.5 meter. And to make our collectible a little more visually interesting, we're going to write up a new script. It's, again, just going to be one line. And all it's going to do is rotate the collectible so it immediately catches the player's eye. So we're going to call this rotate. Open it. Maybe. Here we go. Okay, we don't need start. We don't care about that. So to make our collectible rotate, all we need to do is get the transform of our collectible game object. And we're going to call the rotate function that's part of transform. And you'll notice if you hover over that, it'll tell you that rotate needs vector 3. So that's fine. We can do that no problem. So we'll say new vector 3. And we don't really care what it's rotating at. We just want it to move so the player sees it. So let's plug in like 15, 30, and 45. If we play this right now, it'll move fairly quickly because it'll be moving that many degrees per frame. So let's slow it down a little bit. To do that, you want to call time dot delta time. Actually, let's use fixed delta time. So delta time and fixed delta time, it's just looking for the change in time between the last rendered frame and now. It's the same thing as update and fixed update. Fixed delta time runs, you get the idea. So if we go back to Unity, let's click on our collectible. Let's go ahead and rename it. Let's throw a rotate on it. Okay, so if we play this, our cube should be rotating. Perfect, it is. So it's already visually more interesting. Let's go ahead and throw another material on here just to make it pop a little bit more. Oh, before I apply the material, I'm going to show you why prefabs are cool. Okay, so we have our collectible zeroed out. To create a prefab, there we go. All you have to do is click and drag on whatever you want to prefab, drag it down into your prefabs folder, and you're done. The reason that's cool is if you press Shift-D and you duplicate this collectible a bunch of times, suddenly you have a bunch of instances of that single prefab. Now, let's say you want to make a sweeping change, like you want to change the color on all those. It's a real pain to go into each one and change the material on each collectible. So let's get our first collectible. We'll dump the yellow material on it, and you'll see that it's yellow, the others are not. This is why prefabs are cool. If you go to that first prefab that you tweaked, you go to overrides up here in the right-hand corner of your inspector, click on it, hit apply all. They're all yellow, so you can make sweeping changes on the fly, and it's great. Prefabs are awesome. I love prefabs. I'm sorry, it's good. I have. So this is new stuff. I wasn't going to cover it, but Devitt mentioned it, so we're going in. This is the Prefab Editor. It's where you can basically go in and focus only on creating one prefab. It's really useful for debugging things. So last month I did a level design challenge, and you had to recreate a map from a video game. One of the options was World 1-1, so I remade that, Super Mario Brothers 1-1. I was having this issue with the question mark boxes spawning items. So basically what was happening was I was trying to, the prefab I had for the item, like say it's a fire flower, it was always spawning in at like world position 000 origin, because I usually zero everything out at the beginning. It wasn't taking into account that I needed to like get a position from like this prefab. So too long didn't read, I managed to fix all that in this prefab editor. It's really cool. And you can swap back and forth with these arrows right here. So you highlight one of your prefabs in the scene view, and you see this arrow on the right. You click that, you go right to the prefab editor. And to back out, you click this arrow right here in the hierarchy on the left. You're back in your scene view.
What does it change other than just focus on that one thing? Is it just like zooming in, basically?
It's not really zooming in. It's taking everything else out of the equation.
It's actually going to a different scene almost. You can use that to make variants of your prefabs. So if you wanted one that was red or blue or whatever, did different things, you could make those sub prefabs. And then if you want to scale all your prefabs up by, twice or whatever, you can just scale that face prefab up, and that scales all your variable prefabs up as well.
Do you have a question?
How could you make it so the ball was like it's moving? Is it texture?
No, so we have a rigid body on the ball, right? And then we're applying physics forces to that rigid body through the player controller script that we wrote. So if we actually have to go back to that and make a couple of edits here in a second, but so in the editor, we put the rigid body component on the sphere. Up here, we get a reference to that component. We get the update from the player, and we apply that to the two floats that we created up here. And then to actually apply that movement, we're just calling the add force function, and we're adding a force to that rigid body, and the force is the horizontal input combined with the vertical input.
How to make it visibly look like it's rolling?
Oh, so you could throw material on that. Here, we can actually do that really quick. All right, this is how you create textures really quick and dirty. What is this? Here we go. Okay. Make the player red. Home. Let's get the spray paint. Get gray. Home. Size. Gigantor. Home. Resize. Like I said, usually a texture has to be base 2, so let's just do 128 by 128. Do not maintain that aspect ratio. Perfect. We're going to save it on the desktop. You can save it as pretty much whatever, JPEG, PNG. Unity is pretty flexible with image formats. And I don't know if anyone else heard it, but the specific question was, is there a way we could make the ball moving look a little more visually interesting? Because right now it just looks like it's sliding. Fair point. Hopefully with this texture, I tried to put some speckles on it so you can actually see the ball rotating. So if we go into Unity, don't need to create a folder for that. Let's just go ahead and create, import a new asset. Maybe. Here we go. So we can browse around our computer. Let's look for that texture. We're going to import it. So now we have our texture. We can't drag and drop that like we can a material. To do that, we have to apply the texture to a material. Then we can apply the material to an object. So let's create a material.
Just drag it onto the player.
Can you?
You don't have a player material.
Yeah, that's what I'm doing real quick. So we're creating a new material. We're just going to call it player. And here's the cool thing. This is our albedo map. We drag and drop that into the albedo slot, and I don't have the preview thing. Oh, here we go. So we can kind of preview what it looks like, and it already looks a lot better than just like the gray jank that was going on before. So let's just put that on the player. That actually kind of looks cool.
Yeah, it does.
We'll play it and let's see if that had the desired effect. Oh, that's weird. What?
It's because
Do we still have the...
fixed-
Oh, yep, constraints.
Oh, yeah.
Haha! There we go. And that's actually really cool. Looks like a marble. So that's how you do that. Okay, collectibles. Okay, so next thing. So we're gonna set up the collectibles with Unity's tagging system, which is awesome. So on our first collectible here, you're gonna notice under the name it has a tag. We click on this and we're gonna add our own tag. Let's call it pickup. Now this is important. We're going to reference this later in code. Be sure that what you type here it's case sensitive, so it has to match in code. So save it. Go to our collectible. We'll dump that new tag on here, and then let's go back to our player controller script.
You gonna apply that?
Yes. So we're going to use another function. So Unity has two other built-in functions that I use all the time. It's called well, there are a few, more than two. So there's on collision, and then you have enter and exit, and I think stay, and then on trigger, enter, exit, and stay. So you really have 6. And you can do all sorts of cool stuff with that. What we're going to do here is use on trigger enter. It sets this up for us. So we have an argument for this one. We're looking for a collider called other. So let's just say if the other thing it collides into is a game object, and it just happens to have a tag that's equal to pickup, that's how we would do that. And to make things actually work, ideally we would use a conditional statement, because there's not another way to do that. So there we go. All that is saying is, hey, when this is triggered, and if the thing I ran into has a tag called pickup, then we're going to execute this code. And all we're going to do is pick up the collectible. All we're going to do is just disable the game object. So we're going to say other game object set active, which is just a function of game object, and it takes a Boolean as an argument. So simple true false, and we're just going to say false for we don't want it active. So let's go back to Unity. We have to do one last thing to make this work. Actually, here, I'll show you what happens if we do this right now. It should be nothing. So we have the code there, but nothing is happening. And the reason for this is because Unity is looking for a trigger, not a collision. What's happening with these collectibles right now is a collision, and I can show you that. So if we go on the collectible and we go down to the... Where's my... Oh, yeah, sorry, the box collider. Right now it's a collider. All you have to do to make this work is, do you see this is trigger option? You just check that. And because we're working with prefabs, and prefabs are a beautiful thing, we want to apply that change to all of our prefabs. So now when we run this game, when we run into something, instead of colliding, it should trigger and set the game object to 0. So really the bulk of our work is done. We're getting input, we're applying the input, we've got collectibles. The last thing we really need to do is just set up our win condition. I did notice it's getting close to 8 o'clock. We could end here. Do you want to keep going? Do you guys have time? Okay, cool. I should be done in the next 15 minutes max. Okay, so we're going to set up a game manager to keep track of how many collectibles we've picked up and to set up our win condition, which is basically if you've picked up all the things, you win. So let's go ahead, create a new script. Just going to call it game manager.
I'm gonna go on Kickstarter too. Oh,
Huh?
I'm gonna go on Kickstarter. Like, I need help to $100 to finish the game.
It happens, man. Hey, don't knock Kickstarter. We just saw a successful one. So game manager is a pretty frequently used thing. I forget. I don't know why this. Well, I know why it happens. It's just I'm terrible at explaining things. Game manager is important. That's why it turns into a gear. I wish I could explain it better than that. So let's go and open our game. Let's go ahead and open our game manager. We get all of these functions. It's the same as any other thing. we're going to do something cool with our collectibles. So let's say we want to scatter around collectibles and not really have to worry about keeping track of how many we have in the world. That's really annoying. We can do this cool thing by setting up a private game object array. We're going to call it oh my god, I can't spell. There we go. We're going to call it collectibles. So game object has this really cool function called it's like find all game objects with tag. So what we can do here is set our collectibles array equal to game object big G dot find game objects with tag. Oops, I don't need that there. And here we just define our pickup tag. So now we can just indiscriminately dump collectibles into our game world, and our game manager will pick up how many we have from the get-go and just make the designer's life a lot easier. And I can show you how this works by logging out the length of our collectibles array. So if we go to Unity, it's thinking about what I just wrote. Let's actually create our game manager in the game world. Zero it out. Let's just rename it something simple like input output. And we dump our game manager on it. Now if we run the game, if we have the console open, we should see Unity dump out the number of collectibles in our game world. Here we go. Perfect. So we have 10 collectibles in our world. Now we just need to set up logic saying, hey, if we've collected 10 or more collectibles, you win. Good job. So let's go ahead and do all of this really quick. Let's go back to our game manager. Okay. We want to do a couple more things. We want it to keep score. So we're going to set up an integer, just a whole number. It can't be a floating point. And we're going to call it score. And it's always going to start at 0, so that's easy. So we're just going to go ahead and say that. When the player runs into a collectible, let's say it can call a function to increment our score. So to do that, it's a public function, so it's available if it has from anywhere. We don't want it to return anything, and we'll just say, yeah, that'll be good. Score update. And literally all we have to do here is just score plus plus, done. Perfect. So let's go to the player controller. Now we have to wire in the game manager. So to do that, again, we can make life really easy for the designer. Just set up a public game manager. We'll call it GM. And there are better ways to do this, but hey, it's fine. This is game jam code. Let's go to our player. We have an empty slot for our game manager object, so we'll just drag that in. And that's set up. So now, if we go down to onTrigger enter, let's say GM, I just forgot what we called our function. What was it? Update score? No, score update. Whoop. We can call score update. Here, let's actually log out the value of score. Here we go. And again, we can check our console. We don't have any errors. And if we play, you can also see the output of the console down here in the bottom left. So there's our initial count of objects. And if we bump into this, there we go. Our score is 1, 2, 3. Now, ideally, our player isn't going to have Unity open looking at the console. So let's communicate this to the player in a little bit better way. So Unity has text elements. They're okay. There have been a lot of tweaks to it over time, but what I show you here will get you up and running. So let's, in hierarchy, we're going to create a new UI text element. So that'll do a few things for us. That'll set up a canvas, which is basically what all of the text elements live on, and it'll also set up things with an event system. Unity just automatically hooks all that stuff together. You're good to go. I will say one thing. I don't know why this isn't the default option. On your canvas, If you go to, here we go, the canvas scaler right here, UI scale mode. If you select constant pixel size, that's going to be really annoying. Like, let's say you set your font to like font size 12. Relative to the canvas, with that option selected, it'll always be font size 12. So like, if you run your game at 4K and you've been like previewing it in Unity at like 1080p, the text is going to be really, really, really tiny. So it'll scale with your screen resolution. It won't scale with your screen resolution. That is really annoying. All you have to do to fix that is say scale with screen size. That's the second thing that I want you to walk out with. Prefabs and scale with screen size. I don't know why that's not default. Sorry. Tangent. Okay, so we have our text element here. We can preview it from the game, and you see that we have new text right here. So let's move it to just like the upper left-hand corner of the screen. To do that, you want to tweak the rect transform over here in the inspector. This kind of crosshair-looking thing. Left-click on that, and then with Shift and Alt pressed, you'll kind of see how that'll affect the crosshair over here. Hold that and select this upper left-hand corner, and that'll drag our text into that corner. And we can adjust it a little bit more. Let's drag it out, set it to like maybe 100, and then maybe -50. Perfect. We can do a couple of other things. We can set, like if the text wraps or overflows, we can anchor it in certain positions. We can change the font size, the color. Let's just go ahead and make it, I think black was fine. Let's blow it up a little bit, though. Here we go. Here we go. So this is where we're going to display to the player how many points they have. Let's go ahead and create another text. And this will just be when condition met. There we go. Same thing, and let's center this one. Anchor it into the middle here. We want this to be relatively big. Overflow. There we go. So we have our point value and our uWin screen ready to go. If we go to our game manager, we can start messing with those. Now you're going to need a new namespace for this. So if you go to using Unity Engine .ui, you'll get access to all the different functions and stuff that we need. So to get our text up and running, we need two public text objects. We'll call this one points text, and the other one when text. So on start, we haven't won yet. So we want our when text to be nothing. I messed that up. That's also one of my favorite functions in Unity. It's literally just text.text. So our when text is that. And our points text, let's just say points and then space. Oh, derp, I did the same thing, .text. Now we can change these two by going into score update. So we can take out this log here, and then we can say our points text. Oh. Actually, yeah, that should work. Our points text dot text is equal to points, and then whatever the value of our score is. So whenever we collect an object, this should change our points text. And let's go ahead and hook up the last bit, the when condition. So let's just say if score is greater than or equal to our how much stuff is in our collectibles array, then we can finally set when text dot text equal to you win. There we go. So code-wise, that should work. Let's go over to Unity and connect the wires. So we need to go over to our game object, or sorry, our game manager. Let's hook up, I believe this is, yeah, it's point text here. Let me rename this. This is why it's usually a good idea to stay on top of naming things and keeping your project organized. Let's hook these up. So we have points text and win text. And if we run the game, those should change. Good, so points is 0. And it appears to be incrementing okay. Yep. And boom, we've won. So you've met all the specifications in the earlier slide that I made. And just really quick, I'm not actually going to build this out, but if you want to build your game, ideally it's something you'd want to do, like if you're in a game jam or something, because Ludum Dare and Global Game Jam, they're technically competitions, but not really. To have a submission, you actually have to build your game, but Unity makes that easy. Go to build settings. You can select your build target here. Mine is just set to PC by default, but you have a bunch of other options. The cool thing is, so the Oculus Quest that just came out, you literally just build that out to Android and you are good to go. Like you need the Oculus SDK to actually write the game rules, but it just runs an APK. But that's how you build a game. So yeah, that's the whole intro to Unity. I think I've got just a handful more slides here.
The thing I found with developing for the Oculus Quest, it is very helpful to also have a Rift.
Yeah, I'd imagine.
For debugging.
Yeah.
So you don't have to build to the Quest every time.
Yeah, and I know that we're running over on time, but just really quick. If you want additional resources, additional reading, Bracky's, that guy on YouTube, he runs a Unity tutorials channel. It is great. All of the tutorials are really easy to follow, and he gets into some really in-depth stuff. One of my favorite tutorials that he does is a time rewind mechanic. And Too Long Didn't Read, he basically writes code that will track the transform of a game object over time, and because he tracked it, he can reverse it. It's really cool stuff. Unity also has official tutorials on their website, and also the engine and API documentation is great. It's really easy to follow and read. Like I said, I'm not a programmer by trade. I'm simply a hobbyist, and it's written in language that I can understand. Here's all of our stuff. There's the game jam, not next weekend, but the weekend after. All of our Discord, our Facebook, Meetup. We usually try to post when we do these kinds of things on Meetup and Facebook. Twitter is just kind of, hey, we have a Twitter. And Discord is just our day-to-day life. We just chat in that.
Annie did the...
Oh, yes, Annie did our poster. Thank you, Annie. That is awesome. Yeah, yeah. There was a fight. And again, these are just some screenshots from other Game Jam stuff that we've done. And with that, that's all I've got. So I want to thank you all for coming out. If there's leftover pizza, please take some. If there's leftover drinks, please take some. And I'll see some of you at the Game Jam.